Hello everyone, welcome to our YouTube channel Scientific Research Gurukul Classes. Today we will discuss the history of trigonometry and the concept of trigonometry, basic concept. So here we start. So basically the trigonometry word is derived from two ancient Greek words. First is trigonon and another one is metron. So basically the trigonon means triangle and the metron means measure. Now we can say that in general trigonometry is basically a branch of mathematics which is concerned with the relationships between angles and the ratio of the lengths. So, this field emerged in the Hellenistic world during the 3rd century BC from applications of geometry to astronomical studies. So here is a note point what basically that Hellenistic word means. So basically in classical antiquity the Hellenistic period covers the time in Mediterranean history after classical Greece between the death of Alexander the Great in 323 BC to the death of Cleopatra VII, followed by the emergence of the Roman Empire as signified by the Battle of Actium and the conquest of Ptolemaic Egypt. So the next we will discuss regarding the Pythagoras theorem. So it is a very common concept but most obvious and most important. So basically that Pythagoras theorem is also known as Pythagorean theorem. So basically it defines in any right angle triangle the hypotenuse square. It means the square of hypotenuse is equal to square of sum of square of base and the perpendicular, that we can write h square is equal to b square plus p square. So generally we have to calculate the hypotenuse, so h equals to root over b square plus p square. Also from there we can calculate b. So how we will calculate b? So basically we can calculate from the Pythagoras theorem that b square is equal to h square minus p square, and then we can write b equals to root over h square minus p square. Similarly we can calculate that p also, so that p square is equal to h square minus b square. From there we can calculate that p equals to root over h square minus b square. Now let's deep dive into the Pythagorean triplets. So any triplets that follows Pythagoras theorem. So we will discuss the 5 most common Pythagorean triplets. So here the 5 most Pythagorean triplets are. So first is 3 4 5. If we look into this first triangle, so in right angle triangle the base is 3, the perpendicular is 4, and then the hypotenuse will be obviously 5. Next the Pythagorean triplet is 5 12 13. Base is 5, perpendicular is 12, and that hypotenuse is 13. Next is third Pythagorean triplet, that is 6 8 10. So base is 6 and perpendicular can be 8. So it can be vice versa, like the base can be 8 and perpendicular can be 6, but it is obvious that hypotenuse must will be 10. And next Pythagorean triplet is 9 12 15. So we can consider here the base is the 9 and the perpendicular is the 12, and that hypotenuse is obvious as the longest side, that is equals to 15. Next Pythagorean triplets is 15 20 25. So if we will look here that the base is 15 and the perpendicular is 20, then the hypotenuse is obviously going to be 25. So now we will discuss the basic thing is that trigonometric formula. So like the sine theta, cos theta and tan theta, if we will consider in this triangle ABC, AB is the base B, and that perpendicular the height AC as P, and hypotenuse is H, that is BC. So here we have obvious chart here, that is PBP, HSB and SCT. So what is that? It basically means that P is obviously perpendicular, B is base, H is hypotenuse, and that S is sine theta, C is cos theta, and D is tan theta. So here we have a code words to remember this concept, and that is that Pandit Badri Prasad Hari Hari Bol Sona Chandi Tol. So what that basically means? So here we will look Pandit Badri Prasad Hari Bol Sona Chandi Tol. So Sona means sine theta. So sine theta can be written as P by H. Sine theta can be written perpendicular upon hypotenuse. There we have written sine theta is equal to perpendicular upon hypotenuse. Next is cos theta. So how we will grab this cos theta? Cos theta is basically base by hypotenuse. So here is the Pandit Badri Prasad Hari Hari Bol Sona Chandi Tol. That Chandi is cos theta. So cos theta can be write B upon H, that is base upon hypotenuse. That is from here triangle base upon hypotenuse, right? So next is tall, that is tan theta. So here we can tan theta, we can write like P upon B, that is P upon B, perpendicular upon base, right? So here we have that opposite, that is sine theta, reciprocal is cosec theta. So cosec theta can be written as 1 upon sine theta, that is will be hypotenuse upon perpendicular. Sec theta is the reciprocal of 1 upon that is cos theta. So sec theta is basically the reciprocal of cos theta. So here we can write sec theta equals to 1 upon cos theta, that is hypotenuse upon base, and that cot theta is obviously opposite of tan theta, that we can write B upon P. Here we have a formula about tan theta, and the tan theta is equals to sine theta upon cos theta. So next we have actually trigonometric identities. So we will go with three important trigonometric identities. First is sine square theta plus cos square theta is equals to 1. It is okay, everyone remember this formula, but we need to know what is the use of this formula. So here we will transform this formula into some simpler structures. So from here, that sine square theta, we can write that sine theta equals to 1 minus, so here we can write that, if we will simply, I have not written here but you can understand very simply. So this sine square theta, if we will put in the LHS, then this 1 will be right in the LHS, but that cos square will go that way and it will be 1 minus cos square theta. So obviously sine square theta is 1 minus cos square theta, and from there we can write sine theta equals to root over 1 minus cos square theta. But 1 minus cos square theta, applying the formula a square minus b square, it can be written a minus b into a plus b. So here sin theta can be written as 1 minus cos theta into 1 plus cos theta. Next is, if we will transform this formula into cos theta, so what we can do, so cos theta equals to 1 minus sin square theta, obviously 1 minus sin square theta, applying the formula a square minus b square, we can write 1 minus sin theta into 1 plus sin theta. So similarly we are having the next second trigonometric identity, most important, 1 plus tan square theta is equal to sec square theta. From there, so we can write, if we will send this sec tan square theta that way it will be sec square theta minus tan square. So obviously it will be sec square theta minus tan square theta is equal to 1. So here we will apply the formula a square minus b square. So it will be sec theta minus tan theta into sec theta plus tan theta equals to 1. So from there we can calculate sec theta minus tan theta. So that formula, so this will be multiplied in that LHS way, that will go in that side, it will be 1 upon sec theta plus tan theta. So here we can also send this first part of the denominator, and then this sec theta plus tan theta will be here, and that will be equals to 1 upon sec theta minus tan theta. Then last but not the least is 1 plus cot square theta equal to cosec square theta. It is similar to that one. Here the 1 plus tan square theta is the 1 plus cot square theta. So basically the difference is in if it will be tan square theta, that is 1 plus tan square theta, then it will be sec square theta. But if it will be 1 plus cot square theta, then that will be cosec square theta. So applying the same concept, we can write cosec square theta. If we'll send this cot square theta that way, it will be cosec square theta minus cot square theta equal to 1. Then cosec theta minus cot theta equals to cosec theta plus cot theta. We can write a square minus b square as a minus b into a plus b, right? And that will be 1. So here we can calculate that way. This is whole multiplied, that will go in the RHS side, and that will divide like 1 minus cos theta, this first part 1 minus cos theta equals to 1 upon cosec theta plus cot theta. Similarly, if we write this in LHS, 1 plus that is cosec theta plus cot theta equals to 1 upon cosec theta minus cot theta. So guys, I hope you like our video, and one more thing we want to introduce you, that here you can if you want to grab good marks in 10th and that in the 12th board, so you can join our coaching center. Here we provide the best platform. So how to grab good marks in, or getting the good marks simply means, so we will enhance you to get marks more than 95%. So right, you can join the Gurukul classes, that is SR Gurukul classes, that is Scientific Research Gurukul classes. Thank you for watching. If you like the video, then please subscribe, like and share the video. Thank you. Have a great day.